my name is Rishabh.
Or shall I ask you to?
Hello, good morning. My name is Rishabh. Today I'm going to tell you about star evolution. I am studying in SRS, and my teacher's name is Usha Kulkarni, ma'am. Ma'am, should I start?
What course are you doing related? Yeah, what course are you doing with Himalayan Space Center? So let me ask you questions. You can answer. Maybe that's an easier way. Yeah.
Yes, ma'am.
All right. So thank you all for joining in. Hey, Rishabh, tell us more about your school and your standard where you're studying currently.
I am currently studying in 7th standard of Sharda Residential School OP.
Oh, that's nice. And how? What really makes you interested about space and subject?
I am interested in space because I want to see beyond Earth and out of our solar system.
Okay, and where do you gather this knowledge?
I gather this knowledge from this class, which is the
Part of Himalayan Space Center?
yes, Himalayan Space Center, in which our mentor is Usha Kulkarni.
Awesome. All right. I also understood and learned that you're part of the Astro Space Star Hoppers group. Is that right?
It's nice.
Awesome. All right. Rishabh, thanks all for joining in. Let's hear more from Rishabh on star evolution.
Yes, ma'am. Ma'am, I can't present.
I'm making you the host.
Yes, ma'am.
Over to you, Rishabh.
Yes, ma'am. Ma'am, can you see my screen? Ma'am. Hello.
Yes, we can see your screen.
Today, hello everybody. My name is Rishabh. Today, I'm going to tell you about the evolution of stars and the inside story. This is like the chart of evolution of stars. I'm going to explain each of these following stages in brief. First is a nebula. A nebula is a cloud of gas and dust in space. Nebulae are birthplace of star. The newborn star is when an old star levels its hydrogen and helium behind. This is an image of a Orion nebulae. Then after the star's core is hot enough and it takes nuclear fusion, it is called a protostar. A protostar looks like a star, but its core is not yet hot enough. The nuclear fusion is a fusion of two hydrogen atoms into a helium atom with the liberation of a huge amount of energy. Nuclear fusion occurs only when the internal pressures are very high, a few million degrees Celsius. That is why it is hard to achieve and control. The luminosity comes exclusively from the heat of a protostar as it contracts because of gravity. A protostar are usually surrounded by dust, which is blocks of light that they emit and are difficult to observe in the visible spectrum. This is the image for a protostar. There are three parts of protostar. It is a jet, a protostar, and disk that is covering, which is surrounding the protostar. Next is a T Tauri star. T Tauri stars are the young stars that are born, which are light to a star and are less than 10 million years old.
Hmm.
Yes.
Stars, nebula ಎಲ್ಲ ಹೇಳಿಕತ್ತ ನೋಡು.
Undergoes gravitational contraction. It represents an intermediate stage between the protostar and a low main sequence star. And before the sun became a main sequence star, it used to look like this. Next is a main sequence star. Main sequence stars are stars that are fusing hydrogen atoms from helium atoms themselves.
Please
Most
mute
of
your
the
side for a minute.
stars in the universe, about 90% of them are main sequence stars. The sun is a main sequence star. Towards the end of its life, the star, like the sun, will swell up into a red giant before losing its outer layers as a planetary nebulae, and finally shrinking to become a white dwarf. This is after the main sequence stars loses its outer layers, it becomes a red dwarf. The faintest main sequence stars are called red dwarfs. Less than 1,000 the brightness of the sun. Because of the low luminosity, they are not visible to the naked eye. They are quite small compared to the sun and have a surface temperature about 4,000 degrees Celsius. According to some estimates, red dwarfs make up 3/4 of these stars in the Milky Way galaxy. Proxima Centauri is the nearest star to the sun, which is a red dwarf. Next is a red giant. Red giant are those stars which come after the main sequence star when they lose a lot of the hydrogen and the helium in the shell surrounding a hot, dense, degenerated helium core. If the sun becomes a red giant, the sun would first consume the planets Mercury and Venus completely, and the Earth would be the closest planet to the sun. And red giants have diameter between 10 to 100 times that of the sun. They are very bright, although the surface temperature is lower than that of the sun. A red giant formed during the later stages of evolution as it runs out of hydrogen at its center. It still fuses hydrogen into helium in the shell surrounding a hot, dense, degenerated helium core. As the layers surrounding the core contain the bigger volume of fusion of hydrogen to helium around the core, there is far more energy and pushes much harder against gravity and expands the volume of the star. Red giants are hot enough to turn helium at their core into heavy metals like carbon and calcium. But most stars are not massive enough to create the pressure and heat necessary to burn the heavy elements. So fusion and production stops. Next is degenerate matter. Fusion in a star produces heat and outward pressure, but this pressure is kept in a balance by inward push of gravity generated by the star's mass. When the hydrogen used as a fuel vanishes, the fusion slows gravity's cause the star to collapse in on itself. This creates a degenerated star. Great densities are also possible when electrons are displaced from the regular shells and pushed closer to the nucleus, allowing atoms to take up less space. Matter in this state is called degenerated matter. Next is a red supergiant. As the red giant condenses, it even heats up even further, burning the last of its hydrogen and causing the outer layers to expand outwards. At this stage, the star becomes a large red giant. A very large red giant is often called a red supergiant. And if our sun becomes a red supergiant, it will also consume Earth with Mercury and Venus in the process. Next is a planetary nebula. Planetary nebula is the outer layers of gas and dust, which has no planets involved, that are lost in the star's changes from a red giant to a white dwarf. At the end of its lifetime, the sun will swell up into a red giant, expanding out beyond the orbit of Venus. As it burns through its fuels, it eventually collapses under influence of gravity. The outer layers will be ejected in the shell of gas, which will last a few tens of thousands of years before spreading into the vastness of space. This is an example of a planetary nebula. Next, the white dwarf. A white dwarf is a very small hot star, the last stage of a life cycle of a star like the sun. The white dwarf are the remains of normal stars whose nuclear force of life has been used up. White dwarf consists of degenerated matter with a very high density due to the gravitational effects, i.e., one spoonful has a mass of several tons. This is an After the white dwarf is a novae. A novae occurs on the surface of a white dwarf in a binary system. If the two stars of the system are sufficiently near to each another, material can be pulled from one Cartesian star surface onto the white dwarf. When enough material builds up on the surface of the white dwarf, it triggers nuclear fusion in the white dwarf, which causes sudden brightening of a star. Supernovae. A supernovae is the exploding death of a star, and often results in the star obtaining 1 billion suns for a short time. The brightness of 100 million suns for a short time. The extreme luminosity burst of radiation expels much or all of the star's materials at a great velocity. During a shockwave into the surrounding interstellar medium, these shockwaves trigger condensation is a nebula paving the way for the birth of a new star. If a star has to be born, a star has to die. The great portion for primary cosmic rays come from a supernovae. Then, after white dwarf is a black dwarf. The last stage of stellar evolution is black dwarf. A black dwarf is a white dwarf that has sufficiently cooled that is no longer emits light, heat, or light. Because of the time required for a white dwarf to reach this state is calculated to be longer than the current age of the universe, 3.8 billion years. So no black dwarfs are expected to exist in the universe yet. Then is brown dwarfs. Brown dwarfs are objects which are too large to be called planets or too small to be called stars. These brown dwarfs can be also called as failed stars. Brown dwarfs are thought to form in the same way that all stars do, from a collapsing cloud of dust and gas. However, as the cloud collapses and the core is not dense enough to trigger nuclear fusion. Next is neutron stars. These stars are composed mainly of neutrons that are produced after supernovae, forcing the protons and atoms, electrons to combine to produce a neutron star. A neutron star are very dense. Mass of 3 times of the sun can fit in a sphere of 20 kilometers in diameter. If its mass is any greater, its gravity is too strong that it will shrink further to become a black hole. This is an example of a neutron star. Next is a black hole. Black holes are believed to form from massive stars at the end of their lifetime. The gravitational pull of the black hole is so great that nothing can escape from it, not even light. The density of matter in a black hole cannot be measured, meaning it can be infinite or above. Black holes distort the space around them and suck neighboring matter into them, including stars. Gravitational lensing. Light around a massive object such as a black hole is bent, causing it to act like a lens for the things that lie behind it. This is an example for a black hole. The blue color sphere or an object is a black hole and the red color object is a star. Thank you.
Awesome. Thank you, Rishabh. Anybody has any questions? questions, you can ask the questions to us. We can wait for a minute or two.
I have
How
a
was your
question.
experience preparing the slides, Rishabh? Okay, go ahead. Whoever has a question.
Once you wanted to say something, no?
Yes, Miss, like how much time does it take from the for the protestar to become a teacher?
It might take 1 to 2 million years for it to become, because it must trigger nuclear fusion.
Any other questions?
One.
Managa
Go
is
ahead,
Anaga, yeah.
Go ahead, Anna.
Are there
So, Anaga,
possibilities of
Okay.
yes, ma'am.
No, no.
Are there possibilities that something in the stellar nebulae might become something else other than the star?
no. There might be possibilities, but science has not proven that yet. So no.
Okay.
Good questions. Any more questions? So, Rishabh, how was your experience preparing the slides and why this topic of the lot?
I got this topic because in my school also one of the teachers said to prepare a PPT on anything, so I prepared that over there, and it was really fun to prepare.
Okay, good to know. All right. Any further questions, thoughts, suggestions? I know we have our Himalayan Space Center students as well. If you all want to share any of your inputs or thoughts on star evolution, please feel free to unmute yourself, put on your video if you're comfortable, and share. All right, then we come to an end of the session. Thank you all for joining in. Thank you for this amazing, session and episode. Rishabh, appreciate all your efforts.